Hi folks, welcome back to Physics with Captain Rod. I'm making this one to help you out with number 12 here in your homework. So let's see, a 500 Newton force is applied as shown to the 200 kilogram rock. Assume frictional coefficients of 0.3 and 0.4. Let's see, draw a free body diagram of the rock and then we'll talk about some more of this stuff. Let's chat about this first. So what are these things about? So hopefully you've seen my videos, or anybody else's I guess, on frictional forces. And these are what are referred to as frictional coefficients. They are numbers that are a reflection of the material that you're dealing with. In this case, rock against ground or earth or something. Let's talk about what they mean. The smaller of the two is called the coefficient of kinetic friction, right? So that's this one. That's for dealing with the sliding frictional force. So in this example, right, the sliding or kinetic frictional force is 0.3 times the normal force. For all practical purposes, frictional coefficients are just decimals, right? So that 0.3 means, if this object is sliding, the frictional force will be 0.3 times the normal. The larger of the two is for calculating what's called the static coefficient of friction. Or actually, I like to say the maximum frictional force, really. Let me put that. Maximum frictional force is going to be 0.4 times the normal. So you typically use this one in cases where, like, is it going to break free or not, right? This is definitely used when the thing is static, not moving. This comes into play if the object is sliding, right? Now, Part A, draw a free body diagram of our rock. So we have this 500 Newton force already basically drawn. And then ask yourself, which direction does the mg go? And again, it's got what's called a line of action. You can draw it anywhere along its line. There's a normal force and apparently a frictional force. I don't want to do that for you. I want you to do those. So hopefully you'll get those done. Now, the rest of this problem here, let's see, find the normal force between the ground and the rock. All right. The normal force on the rock needs to be in this direction because it needs to make a right angle to the surface. That's what normal means. So hopefully you have that in your free body in the correct direction. And you can always, in a free body, find the normal, or maybe I shouldn't say always, but let me restate that too. The typical method to start finding the normal is to sum forces in the direction of the normal. So in this example, that's going to be what I'll call the y direction. So that you're going to want to write a proper Newton's second law force equation in the y direction. And in this case, right, that's going to equal 0. In general, Newton's second law is net force equals mass times acceleration. But as we look at this problem, we have a 500 Newton force, and the mass of this object is 200 kilograms, which means it has a weight of around just short of 2,000 newtons. There is no way this 500 Newton force is going to get that rock off the ground. That's why we know that in the y direction the acceleration is going to be 0. You should be able to get the normal out of this. Now once you have the normal, by the way, you can then calculate the maximum possible frictional force, because that's going to be 0.4 times the normal. And you could also calculate the kinetic coefficient of friction, or the sliding coefficient of, or the sliding frictional force, which is 0.3 times the normal. Now, dealing with friction is a little kind of tricky, right? You have to kind of know, well, which one is relevant. So what you have to decide is this rock going to break free or not? To know, is this relevant or not? So the way you tell, you go back to your free body. And for lack of a better way to put this, again, I don't want to work the problem for you, but when you have your free body done, compare the force component that's in this direction of that 500 newtons to your maximum possible frictional force. If this force, right, I'll just say it like this, the component of that 500 newtons that's in this direction is bigger than the maximum frictional force, then you know that rock is going to break free and start sliding. And if that's the case, you know the frictional force now is this one. If the maximum possible frictional force is greater than the horizontal component of this force, then you will know that, okay, there's not enough force to break the thing free, and it's going to stay static. And then the actual frictional force, by the way, isn't equal to this one, right? Because this tells you the maximum possible. So hopefully that'll be enough to get you through this problem. Again, hope you're enjoying these videos. Have a great day.